What's going on, y'all? It's Shotty the Generator. I got another video for y'all today. Yay. Alright, so this is completely different. Off tangent from my normal thing. Alright, today's my birthday. I want to start it off with something a little different. You know what I'm saying? I'm 30 now. So I'm very, you know what I'm saying, technologically smart. You know what I'm saying? I'm from the hood, but you know what I'm saying? I also took some science classes, you know. So we finna look at some possibilities right now. They talk about um you know, like the pressures and stuff like that. I don't sound smart the way I'm trying to explain this. I'm trying to sum it up real quick. But basically, they talk about pressure, you know what I'm saying? And what happens when you squeeze things and what happens when you squeeze water and stuff like that. And so far in the video, I've actually watched some of this video already just because I was actually watching. I was like, you know what? I ain't going to do a reaction to the whole video because it's kind of boring to most people. But I'm finna get into it. So basically, if you squeeze water, what happens to it, right? What happens when you keep squeezing things, right? And they're gonna talk about different atmospheric pressures, and what that means basically the pressure of our atmosphere, right? All right, so we finna just get into it. You know what I'm saying?
Porthole, you can see a couple of these sensors getting moved into place. In 2017,
So basically, this is a big machine that can replicate the center of like the Earth, right? It can replicate pressures that are is heavy as like being in the center of the Earth under all the rocks. You know what I'm saying? That's a lot of pressure. You know what I'm saying? They're gonna replicate that, and then also on different planets as well. See how how heavy things can really be. You know what I'm saying? What it does to matter and
researchers put a tiny bit of ice 7 sandwiched between two diamonds in the target chamber. As the
all right, basically, ice 7 is a form of ice, right? You got H2O, which is ice, which is water, and then if you freeze that or squeeze it, it turns into ice, right? Yeah, if you freeze it, it turns into ice, right? If you take that, that liquid water and you put it in a cube, right, and then you compress it, right? It doesn't do anything to the water. Water doesn't compress until you get it into you know, under the earth. Like once you get down underneath, tons and tons and tons and tons, of, like an unfathomable amount of weight. You know what I'm saying? Once you get under there, it'll change the molecular structure and it turns into ice, and it comes to ice in these numbers that he's speaking of. So basically, instead of the, I should have put a little thing up, but I ain't gonna do it. Look, I'll make it quick. So instead of the molecular structure being in like a hexagonal or octagonal, whatever it is, structure, it's actually turned into square structures. So the ice is way more, it's a different. I don't know if we'd notice if we see it, but it'd be a different ice. Okay, so
shockwave passed through it, pressure in the ice spiked above 2 million atmospheres and its atoms rearranged. Oxygens formed a tight lattice, while hydrogens were free to diffuse through it. It was ice 18, 4 times denser than normal ice and able to conduct electricity almost as well as a metal, for a few billionths of a second.
See, boom. So not only does it change, like the way it may look or stuff like that, but actually the way it acts as a material. So this is not only with just ice though. Check it out.
The laser had recreated conditions inside Earth. Speaking of, let's get back to our journey. As our water starts to turn into ice 18, our glob of sodium is undergoing its own transformation. Under these pressures, scientists have seen it turn transparent. Now, what could account for this? Well, metals like sodium are shiny because they have a bunch of free-flowing electrons that can absorb and then retransmit light, which we see as a reflection.
What happens when you apply pressure to it is you're squeezing the electrons away from their atoms and into these localized pockets.
Trapped like that, the electrons can't interact with light, and so it just passes through.
All right, so boom, right? That right there has me thinking, right? Like, okay, so if basically, you know what I'm saying? Atom, like you think about it, there's always electricity in something. Everything is, filled with electricity, even things that you think aren't. You know, and they're gonna go into probably into a drawn out conclusion of how you can make energy one way that costs a lot of money. But it sounds like all you need is a lot of pressure. You know, if you had a lot of pressure, like then it sounds like you could convert pressure. To me, I'm not that smart. I'm just thinking brainstorming, what they call, what I'm saying. I'm a great thinker. I'm not a great like finder outer. You know what I'm saying? If that makes sense. I can do all the research in the world. Don't mean I'll find the answer to what I'm actually trying to find out. But I can think. I can think about like a problem. I can find a good problem. And I could think about it for a long time. So, like, what if you could like say you have, I don't know, a board, right? And you put that board on a scale, and you put, on both sides of that board, put a big rock on both sides. We're gonna say a rock or a weight. We're gonna say 50-pound weight on each side. That's gonna be 100 pounds worth of weight, right? But like the pressure that it makes, like that's like potential energy, right? So if it's pushing on a wheel, potentially it's 100 pounds worth of force or more, right? So like, why can't we just take that stationary object that's not moving and harness the potential energy? Like, why can't we? I don't understand.
We've reached the center of the Earth, but that's not the end because we can continue into pressures found.
Like if you place, if you put a rock, like right, boom, straight on the ground. Like if you had a sensor under there, I could say, oh, that was so much pressure. It weighs this much. Why can't we take that and just do something with it? I don't understand yet. Maybe we're not that smart yet.
Found inside larger planets. Tens of thousands of kilometers below Jupiter's surface, physicists think hydrogen will go through another change, becoming a shiny conductor of electricity. It's thought that a lot of Jupiter is made up of this metallic hydrogen.
We think of high energy density materials as completely inverting the periodic table. So your metals become transparent and your transparent materials become metals and all these gases become solids.
And the universe holds higher pressures still. The center of Jupiter sees over 10 million atmospheres, just about the highest pressure that the Omega laser can create. And now we're diving into the sun, where pressures rise over 100 billion atmospheres. The island of Manhattan balanced on a phone. We've seen extreme pressures overwhelming the forces that keep molecules apart, but here within the sun, they can overcome the very glue that holds atoms together. Here, individual hydrogen nuclei can be fused to form helium.
Wait a minute. Pause. Okay, wait a minute. Okay. No, because I'm just saying, like, boom, right? I was thinking, like, they saying if you had Manhattan, that I was going to say Manhattan is on the ground and it's pressing, like, why isn't there fusion? You know what I'm saying? But I guess there is warmth on the inside of the earth, so I guess there is some type of fusion. But that just goes to my point, right? That more, if you got pressure, it's potential energy that can make, something. So if you just had enough weight that you set on something, and you can figure out how to harness the energy, the potential, energy from it just either hanging or being down on the ground. You could like put some type of sensor on it. You can actually like use the energy that's being, because we're always moving. There's got to be some way to tap into it, man. We got to be smarter than than what we're trying to do. You know what I'm saying?
A process that releases energy. This is nuclear fusion, the ultimate source of all energy in our solar system, the reaction at the center of every twinkling star. If we could somehow recreate this process on Earth and keep it going, we would have a near limitless source of clean, cheap power.
Exactly.
And researchers are,
you know what I'm saying? Instead of, and they think, look, I was gonna say, what are you gonna say?
Around the world are using giant lasers, including Omega, to study.
Think about that. They're trying to use giant lasers. What does it take to power a giant laser? A whole hell of a lot of energy, right? What does it take to power, you know what I'm saying, a giant, stone sitting on the ground? Nothing. If you could figure out a way to lift up the boulder, set it out on like an energy pad, all that thing, something that just like turns, like the pressures that it make. Like I don't, you know what I'm saying? I'm still trying to figure out how to do it. I'm still thinking in my head like there's no movement, so it's not gonna be like, but it should be like a way to like set it down and be like, like when you put your phone on a charge pad. You know what I'm saying? Just be like, boo. You know what I'm saying? Like the pressures that it makes. Like, I don't know. We still gotta figure that part out. It's some quantum math though. It'd be something quantum as fuck. But hey, this might wrap this video up though. I appreciate y'all if y'all made it this far in the video. It's a little more some intellectual stuff right here. But like, comment, subscribe. Made it this far. We're gonna keep going. All right, peace.